I'm gonna call me Luther. Can you be my tutor? We want to feel like tutor. Can you be my tutor? We want to feel.
Hello everyone, a happy 2026 to you all. This is your favorite tutor. I know it's been a while since the last math tutorial, but let's jump straight into it. In today's lesson, we are going to be looking at the 4 steps you can use to display a set on a number line. And to do that, we are going to utilize this question right here from Math 1110 Test 1 2024. So let's take a look at what the question says. The question here reads, let x equals -2, 10 be the universal set. Given that a is equals to -1, 7, b is equals to 0, 8, and c is equals to -2, 7, find a complement intersection b union c and display your answer on a number line. So we're basically being asked to utilize the information we've been given in this question to basically find a complement intersection b union c and then display our final answer on a number line. So the first step that we're going to take in order for us to display the set a complement intersection b union c on the number line is to identify all the sets in the question. And to help us identify all the sets in the question, we're first going to list down all the sets. So the reason why we are listing down all the sets in this question is because we want to have a clear picture of all the information we've been given in this question. When we have a clear picture of the information that we have, it becomes easier for us to arrive at the solution that we are looking for, which will eventually help us display the set a complement intersection b union c on the number line. So let's do that. So we're going to start with our universal set here, which is x is equals to -2, 10. Then we're going to have set a here, which is -1, 7. And then we're going to have set b, which is 0, 8. And then we're going to have set c, which is -2, 7. We are also going to list down our main set. Our main set is a complement intersection b union c. Do we know what it is? Not yet. So we're doing this to find it and then eventually display it on the number line. So now that we've listed down all the sets in the question, we're going to move on to understanding the structure of the sets. By understanding the structure of these sets, we mean what type of intervals do these sets have, right? Are they closed intervals? Are they open intervals? Are they half open or half closed intervals, right? When it comes to the boundaries of the sets, right? The lower boundaries and the upper boundaries, are they included in these sets or are they not included in the set? What type of set operations are being performed on the main set of this question, right? So we want to have a clear picture of all these things because it will help us know how exactly to answer the question that we've been given right here. So let's begin the process of analyzing our sets so that we can understand their structure. Let's start with the universal set x. So with x, it begins with square bracket, and then we have a lower boundary of 2, and then an upper boundary of 10, and it ends with a square bracket, or it closes with a square bracket. So whenever we have square brackets on both ends of the boundaries, it means that the set is a closed interval. So a closed interval basically means that the lower boundary -2 is part of set x and the upper boundary 10 is also part of set x. So both boundaries, the lower boundary and the upper boundary, are included in the set. They are part of the set. So when we list down set x, all those elements starting from -2 to 10 are part of the universal set. When we look at set A, we have a parenthesis and then we have -1, which is the lower boundary, and 7, which is the upper boundary. When we have a parenthesis on both ends of the boundaries, this means that this set is an open interval. And what does it mean when a set is an open interval? It means that both boundaries of the set, right, the lower boundary and the upper boundary, are not part of the set, are not included in the set. So both -1 and 7 are not included in set A. However, the elements between -1 and 7 are part of the set. So that means that 0, 1, 2, 3, 4, 5, 6 are part of set A, but -1 and 7 are not part of the set. So an open interval just means that the lower boundary -1 and the upper boundary 7 are not included in the set, are not part of the set. Set B here starts with a square bracket, just like the universal set X, and then we have a lower boundary of 0 and an upper boundary of 8. And just like the universal set, this is a closed interval. This means that both 0, the lower boundary, and 8, the upper boundary, are included in the set, are part of set B. Now let's move on to set C. When we look at set C, it's similar to set A. With set C, we have -2, and then we have 7 here, which is the upper boundary. This means that set C is also an open interval. What this basically means is that -2, the lower boundary of set C, is not part of set C, as well as 7, the upper boundary of set C, is not part of set C. However, everything between -2 and 7 are part of set C. Now let's move on to our main set. Our main set is A complement intersection B union C. So we want to have a good picture of the set operations that we are going to be dealing with in this question. So we can see that there's complement here. So eventually we are going to have to know what A complement is. And then we also have intersection here. So we're going to have to find this intersection of A complement intersection B, which is this guy here. So, and then we are also going to have to find the union of A complement intersection B and the set C. So we now have a good picture of the operations or the set operations that we are going to be working with in the question. So just a small point to note when it comes to the intervals of the set. So we can see here that we have closed intervals, we have open intervals, right? At the same time, we can also have half open intervals or half closed intervals. So whenever a set starts with a parenthesis, then it ends with a square bracket. This set is a half open interval. However, if the set starts with a square bracket and closes with a parenthesis, this would mean that this set is a half closed interval. So these are the other types of intervals that we're going to be dealing with as we solve questions like this. So having done all of this, we've completed the first step of the question, which is identifying all the sets in the question. We've listed down all the sets right up here, and then we've gone on further to understand the structure of these sets by knowing what type of intervals these sets have, also knowing or finding out whether the boundaries of these sets are included or not included in the sets. And then we've also taken a look at the set operations that we're going to be working with in the question. Now that we have completed our first step of identifying all the sets in the question, let's move on to the second step, which will help us achieve our goal of displaying the main set on a number line. The second step we're going to take to help us achieve our goal is to break down the set we want to display on the number line and find the individual sets that make it up. So we are doing this because we want to have a clear picture of the main set, number one. Number two, we want to find and know the exact elements that are included or not included in the main set. So whenever you have something big, it might be difficult for you to understand it in its big size. So you might want to reduce it into smaller elements or into smaller chunks. That way you can analyze the smaller chunks individually, giving you a clear picture of how the whole thing is made up or a clear picture of how the whole thing works all together. That way you know the exact elements that go into making that particular thing. In the same way, we're basically going to break down our main set A complement intersection B union C into smaller chunks so that we can know the exact elements that are included or not included in this main set of ours. So the first thing that we're going to do is separate A complement intersection B from its union with set C. So to do that, we're going to have A complement intersection B, all right, on its own, and then we're also going to have set C. Set C is already simplified and we already know what it is. We know that it's -2, 7. However, we do not know A complement intersection B. In order for us to know A complement intersection B, we need to break it down further. So we're going to separate A complement from its intersection with set B. So we're going to have A complement on its own, and then we're also going to have set B on its own. So we already know what set B is, all right? We know set B here, it's 0,8. We've already been given set B in the question. What we do not know is A complement. So in order for us to find A complement, we are going to utilize two sets. So the two sets that we're going to utilize to find A complement are the universal set, because the universal set, remember, includes set A, it includes set B, it includes set C. It's basically the parent set, so we need to utilize it in order for us to know what exactly A complement is going to be. So it will give us a good picture with regards to what elements are included or not included in the set A complement. So what do we have with regards to our universal set? Our lower boundary is -2, and our upper boundary is 10, and then we have a square bracket. And the other set that we're going to utilize to help us find A complement is the set A itself. And we know what the set A is. It's -1 as the lower boundary and 7 as the upper boundary. So we have that established. So we have our universal set and we have our set A. The best way of looking at this is to list down set X, or the universal set, in set beta notation, and we're also going to list down set A in using set beta notation, just to give us a good understanding of what exactly is going on, because sometimes when you're using set interval notation is more like a shortcut of describing a set. But let's utilize set beta notation as well, just give us a clear picture of what's going on. To do that, we're going to have X here, and then we're going to have our braces. We're going to have -2 as our first element, because remember that -2, the lower boundary here is included, so we're also going to include it when listing down the set. So -2 and 10, and then we're going to close with a brace there, and then we're going to have set A here. Remember that set A has been described with parentheses on both ends of the boundaries, meaning that -1 and 7 are not included in the set. So if we were to list down set A using set beta notation, we are not going to include -1 or 7 in this set. That means that the element that we're going to start with here is 0, the element after -1, right? So 0, and the last element is going to be 6, the element before the upper boundary of 7. So we're going to close there with a brace. And please note that when answering your question during an exam, test, or whatnot, you will not have time to basically list down all of these guys in set beta notations, but this is just to give you a good picture of what goes on behind the scenes when we're utilizing interval notation. So now let's move on further to find A complement. Remember that A complement is simply just all the elements that are not found in the set A. So the first thing that we're going to do here is basically now look at the information that we have in our universal set, and also look at the information that we have in our set A in order to know exactly which elements go into the set A complement. So let's have our A complement here. So when we look at the universal set, we see -2. -2 is the first element in the universal set. That means that -2 is going to be our first element in A complement because it's not part of set A. We are going to start with a square bracket, so we have -2. Now that we know that -2 is our first element in the set A complement, let us find the next element after -2 that is also part of A complement, or rather, let us find the next element after -2 that is not part of set A. When we look at -2, the next element that comes after it is -1. And if we look at our set A, right, we have -1 there. However, we see we have a parenthesis here. Therefore, -1 is going to be the next element that is included in our set A complement because it is not included in A. So we're going to have comma -1. So this is going to be our first part of set A complement. We have just found the first part of our A complement, which has the elements -2, -1. However, it is important to note that these are not the only elements that are in A complement. We have other elements that are not part of the set A. These are just the first two elements that are not part of set A, or that are part of A complement. The other elements are 7. Remember that we have 7, which is also not included in set A when we look at our set A up here. And if we look at our universal set here, we can see that our universal set ends at 10, and 10 is also not included in the set A. Therefore, all the elements starting from 7 up to 10 are also not part of set A and are part of A complement. Therefore, we also have to describe these elements from 7 up to 10 using interval notation. A complement is going to be -2, -1 in union with the other elements that are not part of set A. And we know that these elements are starting from 7 all the way up to 10. So we're going to say union 7, 10. We are going to close this second part with a square bracket. So now we can say that we have completely found the set A complement. Our set A complement is -2, -1 union 7, 10. This is our A complement. But there might be some of us that do not understand why we had to unite these two parts here. So we're going to utilize set builder notation here, our lists of set X and set A, to basically understand our final answer here of A complement. So we're also going to list down our set A complement using set builder notation. So if we look at our two sets here, the universal set and set A that have been listed down using set builder notation, we can use this two to basically find A complement. Set A starts from 0 up to 6, and A complement is everything that is not in the set A. So everything before 0 and everything after 6. This is what will make up our A complement. So we are going to have our brace here. And when we look at the universal set, we can see the elements that are not part of set A. We see that -2 is not part of set A, so we're going to put it there in A complement. -1 is also not part of set A, so we're also going to put it in A complement. We can see that this part here that we've listed down already here resembles the first part of A complement that we described using interval notation, where we have -2 and -1. Now let us find other elements in the universal set that are not part of set A. Set A ends up to 6. That means that 7, 8, 9, and 10 are not part of set A. Therefore, 7, 8, 9, and 10 are going to be part of A complement. So we're going to have 7 and 10. So we've listed down our set A complement. If we look at this combination of elements that we've listed down here towards the end, we can see that this part resembles the second part of A complement that we described using interval notation. So this part is the same as that part, and this part is the same as this part. When we list down the set A complement, what we're simply doing is just uniting this first part and the second part. So we're basically just uniting this part and this part, making it one. This just means that we are uniting the elements before 0, which are -2 and -1, with the elements after 6, which are 7 and 10. Henceforth, we'll write down our final answer here of A complement. A complement is equals to -2, -1, union 7, 10. So this is our final answer for A complement. So now that we know what A complement is and we also know what B is, let us find A complement intersection B. To do that, we are going to just describe our set B here using interval notation. So our set B is 0, 8. Both 0 and 8 are part of set B. We know that A complement intersection B just simply means what is common in the set A complement and in the set B. So when we look at the first part here, -2, -1, and we look at our set B here, 0, 8, we can see that -2, -1 is before 0, which is part of set B. Therefore, there is nothing common between the first part of A complement and set B. That means that we have to look at the second part of A complement, which is 7 to 10. If we look at our set B down here, we can see that set B starts from 0 all the way up to 8. And 8 is included, 0 is also included. When we look at the second part of our A complement, it starts from 7 all the way up to 10. What elements are common between this part of A complement and set B? We can see that 7 is also part of set B because remember, the highest element in set B is 8. And 7 comes before 8. Therefore, 7 is also going to be included in the set A complement intersection B, and it is going to be the first element in our set A complement intersection B. So 7 is our lower boundary and the first element of our set A complement intersection B. Now, let's analyze further. The second part of A complement ends up to 10. However, 9 and 10 are not part of set B because set B ends up to 8. So 9 and 10 are not going to be considered, which means that in this case, the only other element that is common between set B and set A complement is 8 itself. So 8 is going to be our upper boundary and last element in the set A complement intersection B. and we're going to close it with a square bracket because it is included in the set B. Therefore, it is also going to be included in the set A complement intersection B. And just like that, ladies and gentlemen, we have found the set A complement intersection B, which is 7, 8. Now that we have found what our A complement intersection B is, we have all the ingredients that we need to find our main set, which is what we are going to do in our next step. So let's move on to our next step. So the third step that we're going to take to help us achieve our goal of displaying our main set on the number line is to find the elements of the main set. And to do this, we're going to first put the individual sets back together to obtain the original main set. And then after that, we are going to utilize the elements of the individual sets that we found in the previous step to find the elements of the main set. So let's do just that. We're going to start with the first part here, which is putting the individual sets together. Remember that previously in the previous step, we broke down our main set. Our main set is A complement intersection B union C. And we further broke it down into two parts. This part and this part. We separated these two parts, if you remember or if you recall. We had A complement intersection B on its own, and then we had set C on its own. We separated the two. So now what we are doing is connecting these guys back together with a union operation so that we have our main set back together, which is A complement intersection B union C. And remember that we've already found what our A complement intersection B is. We know that our A complement intersection B is equals to 7, 8 with square brackets at the lower boundary and at the upper boundary to denote that both 7 and 8 are part of the set A complement intersection B. We also know what our set C is. So now if we pay close attention, we've moved on to the second part, which is utilizing the elements of the individual sets to find the elements of the main set. All right, so we're utilizing the elements of these individual sets to find the elements of this main set. So let's describe C using interval notation. So we have -2, 7. So these are the elements in set C. So the lower boundary is -2 and the upper boundary is 7. However, the lower boundary and the upper boundaries of the set C are not part of set C. So A complement intersection B is a closed interval and set C is an open interval. So we now have the elements of both our individual sets. So we're going to use these elements now to find our main set. And remember, our main set is A complement intersection B union C. Now we begin the main process of finding the union of A complement intersection B with the set C. The union of two sets is basically the process of combining the elements of two sets together in order to obtain one set. So we're just going to combine these elements here, 7, 8, and the elements -2, 7. Remember, we are just combining the elements of these two sets together. That means that the elements of this set and the elements of this set have become one. So in order for us to basically describe the union of these two sets using interval notation, we simply just have to find the lower boundary from the combined elements and the upper boundary from the combined elements. So in this case, when we look at the elements in A complement intersection B and the elements in the set C, we can see that -2 is the least element. Therefore, -2 is going to be the first element in the set A complement intersection B union C. However, it is not going to be included because it has a parenthesis. It is not included in set C, therefore it is also not going to be included in the union of these two sets. So we're going to start with a parenthesis. We're going to have -2 as our first element or as our lower boundary, and it's not included in our main set. So what then is our upper boundary? When we look at the elements in both sets here, which element is the highest? We can see that 8 is the highest. Therefore, 8 is going to be our upper boundary in the set A complement intersection B union C. But then we need to determine whether 8 is included or not included in the union of these two sets. When we look at the type of bracket that 8 has here, it has a square bracket. And because it has a square bracket, this means that 8 is part of the set A complement intersection B. And because it is part of this set, it is also going to be part of A complement intersection B union C. Therefore, just by finding our lower boundary and our upper boundary and determining whether our lower boundary is included or not included, and our upper boundary is included or not included, we have described the set A complement intersection B union C using interval notation. We have basically found our main set. So now that we have found our main set, we have all the ingredients that we need for our final step. So let's move on to our final step. The fourth and final step in answering this question is displaying the main set that we have found on the number line. And to do that, we are going to first begin by determining whether the lower and upper boundaries of our main set are included or not included in our main set. And then we're going to move on to further display the set on the number line. So our main set is A complement intersection B union C, and it is equals to open bracket -2 comma 8 square bracket. And if you pay attention to this set here, you'll notice that this set is a half open interval because it starts with a parenthesis here and then it ends with a square bracket. So it's partly open and it's partly closed. So let's begin with our lower boundary -2. If we look at -2, it has a parenthesis on its end. That means that -2 is not included in the main set. If we move on to our upper boundary 8, 8 has a square bracket on its end. And because 8 has a square bracket on its end, it means that it is included in the set itself. Okay, so now the reason why we need to know whether the lower boundary and the upper boundary are included in the sets is because we need to know how exactly we are going to represent them on the number line. So if a boundary is not included in the set, we represent it using an open circle on the number line. On the other hand, if a boundary is included in a set, we represent it using a dot or a fully shaded circle on the number line. I'll repeat that again. If a boundary is not included in a set, we are going to represent that boundary using an open circle on the number line. And if a boundary is included in a set, we are going to represent that boundary using a dot or a fully shaded circle on the number line. So that's the purpose of doing this. So now that we know which boundary is included and not included in our main set, we can move on to the next part, which is displaying our set on the number line. So we're just going to draw a solid line which represents our number line. We are going to utilize the elements in the universal set because the universal set has all the elements that are in the other sets. It's much easier that way. So we're going to start from -2 and 10. So we have our number line here and we have all the elements in our universal set listed down here. These are our coordinate points. Okay, so now let's begin the process of basically displaying our set A complement intersection B union C on the number line. Let's look at the boundaries of our set. We have -2 as our lower boundary and 8 as our upper boundary. -2 is not included in our set and 8 is included in our set. Because -2 is not included in our set, we represent it with an open circle. Because 8 is included in our set, we represent it with a dot or a fully shaded circle. So let's first start by representing our lower boundary -2 on the number line. Let's look for the coordinate point -2. We can see that our point -2 is over here. So just above it, we are going to draw an open circle because -2, our lower boundary, is not included in the main set. So now let's look at our upper boundary. Our upper boundary is 8 and 8 is included in our main set. So we're going to represent it using a dot or a fully shaded circle. So let's look at the coordinate point 8. So 8 is over here. So just above the point 8, we're going to represent our upper boundary here using a fully shaded circle or a dot. So just by doing this, we have represented our upper boundary on the number line. And the final step of basically just representing our set on the number line is connecting our two circles here using a solid line. So we're going to start from the open circle and we're going to go all the way up to the fully shaded circle. Just by doing this, we've basically displayed our main set A complement intersection B union C on the number line. This right here is our set A complement intersection B union C. And just like that, ladies and gentlemen, we have come to the end of this video. Thank you very much. Please feel free to like, comment, and subscribe. If you'd like some free detailed notes on the 4 steps we have discussed in this lesson, please feel free to click on the link below. And if you'd like to interact further, ask questions on how to solve questions like this or any other questions in math, please feel free to join our WhatsApp group using the link below. So thank you very much once more, and see you in the next video.
Can you be my